Hello students, I am Dr. Rajaram Dhok from Savitribai Phule Pune University affiliated Agricultural Development Trust Shardabai Pawar Mahila College Sharda Nagar Baramati. Let's start. We learn about the crystal field theory lecture 5. In this lecture, we discuss about the crystal field stabilization energy of octahedral complex. In the last lecture, we have seen about the distribution of electron in the d orbital. And when that electrons are filled in the d orbital, then filling of electron in T2g or Eg, it depends upon the strong field complex and weak field complex. Here, on the basis of the strong field complex and weak field complex, we also calculate the crystal field stabilization energy, and that is the various. So firstly, we see what is the CFSE or crystal field stabilization energy of octahedral complex. So total decrease in energy caused by the splitting of the d orbitals and their occupancy by electrons, that is called as crystal field stabilization energy. When this CFSE is formed, then at that time some electrons are paired and it forms pairing energy. This pairing energy is also involved in the CFSE. This CFSE is calculated by simple formula. In that formula, we take the energy of T2g orbital and Eg orbital, and in that multiply by number of electrons filled in that corresponding orbitals. So for the calculation, we use simple formula, that is CFSE for octahedral complexes is equal to minus 4 dq into number of electron in T2g orbital plus 6 dq into number of electrons in Eg orbital. So by using this formula, we can calculate the CFSE for different cases, that is from D1 to D10 cases. Firstly, we calculate the CFSE for strong and weak field complexes for D1 case, D2 case, D3 case, D8, D9 and D10 cases. Because in these cases, in both strong field and weak field complexes, CFSE values are same. So we see firstly the values for D1 system. In D1 system, T2g orbital fills 1 electron. And for this, CFSE is minus 4 dq into 1, that is equal to minus 4 dq. For D2 system, T2g fills 2 electrons. And for this, CFSE value is minus 4 dq into 2, that is equal to minus 8 dq. In D3 system, these 3 electrons fill in T2g orbital. And for D3 system, CFSE is equal to minus 4 dq into 3, that is equal to minus 12 dq. Now we see the values for D8 case. In D8 case, 8 electrons are filled in T2g and Eg. Out of that, 6 are filled in T2g and 2 are filled in Eg. So for this D8 case system, we calculate the CFSE, that is equal to minus 4 dq into 6 plus 6 dq into 2 plus 3p, because here 3 pairing energy is present, and so we add that 3p in this CFSE value. So that is equal to minus 12 dq plus 3p. Then D9 system. In D9 system, 9 electrons filled in T2g and Eg. Out of that, 6 electrons filled in T2g and 3 electrons in Eg. So we write electronic configuration T2g6, Eg3. So this configuration, we calculate the CFSE, that is equal to minus 4 dq into 6 plus plus 6 dq into 3 plus 3p, that is equal to minus 6 dq plus 4p. Then D10 system. In D10 system, 6 electrons filled in T2G and 4 in EG. So in this case, CFAC is equal to minus 4 dq into 6 plus 6 dq into 4, and by calculation we get value that is 0. So in this way, in the strong field and weak field complexes, in that cases the values are same. For D4, D5, D6 and D8 systems, in strong field and weak field octahedral complexes, the values are different. So we calculate TFSE in strong field complexes. So for the strong field complexes, in D4 system, T2G fills 4 electrons. And so electronic configuration in D4 system is T2G4. And for that, CFSE is equal to minus 4 dq into 4 plus p. And by calculation, we get minus 16 dq plus p. For D5 system, 5 electrons filled in T2G. And for that, CFSE value is equal to minus 4 dq into 5 plus 2p. And so by calculation, we get the value minus 20 dq plus 2. For D6 system, T2G fills 6 electrons, and for this CFSE is equal to minus 4 dq into 6 plus 3p, and that is equal to minus 24 dq plus 3p. For D7 system, T2G fills 6 electron, EG fills 1 electron. And for this D7 system, CFSE is equal to minus 4 dq into 6 plus 6 dq into 1 plus 3p, and by calculation we get the values of this D7 system final value, that is minus 18 dq plus 3p. So in this way we see the values in strong field. Now we see same cases in the weak field complexes. So firstly we see for D4 system, when there is weak field complexes, then electrons singly filled in T2G and then filled in the EG, and after filling electron in EG singly, then pairing is started in T2G. So for D4 system, the electronic configuration is T2G3 EG1, and in this case we calculate the CFSE, that is equal to minus 4 dq into 3 plus 6 dq into 1, that is equal to minus 6 dq. For D5 system, the electronic configuration is T2G3 EG2, and for this CFSE is equal to minus 4 dq into 3 plus 6 dq into 2, that is equal to 0. For D6 system, electronic configuration is T2G4 and EG2 for weak field complexes. Here CFSE values we can calculate. CFSE is equal to minus 4 dq into 4 plus 6 dq into 2 plus p. So its final calculation is minus 4 dq plus p. For D7 system, here electron is filled T2G5 and EG2. And for this, CFSE is equal to minus 4 dq into 5 plus 6 dq into 2 plus 2p. That is equal to minus 8 dq plus 2p. So these CFSE we can calculate in weak field complexes. Now in this weak field complexes and strong field complexes, the CFSE values are different. So we see these all the values in one table, and we compare that which complexes are stronger and which complexes are weaker. So you see this table here, different D cases, that is from D1 to D10 is given, then its weak field configuration is given, and its CFSE values are also given. And in that weak field complexes, how many unpaired electron present, that is given in column. Now same type here in strong field complexes, the configurations are given, its unpaired electrons are given, and its CFAC values are given. Now, we just here seen in case of the D1, D2, D3, then D8, D9, and T10, here strong field and weak field electron distribution is same. So we see here in D1 case -4 dq in weak field, -4 dq in strong field. D2 case -4 dq, -8 dq, -8 dq in strong field. D3 case -12 dq in weak field and -12 dq in strong field. Now D4 system. So this is important. You see here in D4 system in weak field complexes electron distribution is T2G3 EG1 and in strong field complex T2G4. Now you see in the weak field complex here value is -6 dq. In the strong field complex value is -16 dq plus P. So from these two values we can easily identify this higher value shows that this is the strong field complex. Now we see the number of electron in strong field and weak field. We see here in strong field complex in D4 case 2 electrons present and in weak field complex 4 unpaired electrons present. So this 4 value and 2 value when we compare, then we can see that this weak field complex contains high spins, and so this weak field complex is also called as high spin complexes, and strong field complexes that is called as low spin complexes. Now we see the D5 case. In D5 case, weak field complex shows zero energy of CFAC, and in strong field complex energy is -20 dq plus 2. In this case also, you see in weak field complex unpaired electrons are 5 and in strong field complex unpaired electrons are 1. So unpaired electrons in weak field complex is higher, so this is the high spin complex, and strong field complex is low spin complex. So in every example, in every case where the strong field and weak field have different electronic configuration, it shows that strong field complex contains low unpaired electron or less unpaired electron, and weak field complex contains more number of unpaired electrons. So that is the high spin complex. Now you see here D8, D9 and D10. In that same number of electrons present, that is, and electronic configuration is also same. CFAC values are also same. So in D8, CFAC value is -12 dq plus 3p. In strong field also that is same value. In D9 case, -6 dq plus 4p in both weak field and strong field. In D10 case, here value in strong field and weak field is 0. So from this table, we can easily identify that strong field complexes have higher value of CFAC and weak field complexes have lower value of CFAC. Then weak field complexes contains more number of unpaired electron with corresponding strong field complexes. So weak field complexes are called as high spin complexes and strong field complexes are called as low spin complexes.